Okay, so you guys did the spreadsheets. Spreadsheets are great for small amount of data, right? Personal information, I think I told you guys, I keep, I track all sorts of stuff in spreadsheets at home, just personal information, not a ton of information. It's not stuff that I want to be accessible out on the web, it's just kind of my personal data. And you played around with formulas, so you can do calculations on that stuff. There was I don't know if I told you guys this, but when I bought my first home, I built a spreadsheet that would show me how my principal amount, how my remaining amount due, my total amount that I still owed on my home would be affected if I paid extra money each month when I made a house payment. And so that really encouraged me to pay off that house sooner, because I could see how much just putting an extra $50 in on this particular payment, how much that affects the overall. It's really astounding if you do like a 30-year loan, because you're paying most of your interest on a big loan like a home loan. You're paying most of that interest up front, and so just like even putting in a little bit of money extra as you're making payments has thousands of dollars different than what you pay over the life of a loan. So that's a helpful tool that you can use a spreadsheet for. And you can even use, especially with what Microsoft is doing now with since Excel is now online, right? You can store spreadsheets online. You could even write stuff where you could access it over the cloud and things like that. But if you're using a lot of data, right, and you've got multiple people that are accessing that data, you're probably going to store your information not in a spreadsheet, but you're going to store it in a database. All right, so let's figure out how do we distinguish a database from a spreadsheet. There's some similarities. When doing the spreadsheet exercise, we'll kind of prepare your mind for working with databases. You still have you have tables, and I don't know if we use that term, but a table sort of corresponds to a single tab on your spreadsheet, right? So I don't even know if you guys noticed you can have multiple tabs. It stands out a little more in Excel. Let me see how it looks on Google Sheets. I don't know. Does anybody want to volunteer to let me look at their spreadsheet in class? Yeah, Hudson's volunteer. I should put your name on the board. Oh, it's right there.
Hey, look at mine.
See, that's why he's always up there first, Stephen. Did you see how he just immediately volunteered? So let's go to Google Classroom. Oh, not the Code Tutor. That's the wrong one. Okay, so anyway, so we're looking at Hudson's high quality spreadsheet here, right? Top notch. And what I was talking about just then, when I mentioned tables on databases, right? It's you can sort of think of that like your sheets down here. So like you have a sheet here, and I could duplicate, well, if I don't want to do this on Hudson's, but if I did that, I'd get like sheet 2 down here as well, right? So you could create multiple sheets, and so you'd have multiple pages where you see like a spreadsheet. You'd have a unique spreadsheet for each page. And so we can sort of think of that as tables in databases. I can have multiple tables in my database. And we have tables. Tables are made up of rows and columns. That sounds like our database, right? I mean, our spreadsheet. So we had a spreadsheet, right, that looked like a grid like this. And, right, that's kind of how our spreadsheet is divided. You guys, Gracie's especially impressed with the high quality artwork here, right? It's very similar to the drawing that she did. Thank you very much. Can you see my reflection? I did like a little image down here. No. Okay. So this works fine, in a spreadsheet form for small pieces of data, but in a database, spreadsheet's eventually going to have a limit to the number of rows, number of columns. Yes?
When it's talking about the databases, is it talking about key value style databases?
Uh-huh.
Okay.
Yep. So, excuse me. At some point, Excel is going to say that's too many rows, right? And there's a file size limit when you configure databases as well, but it's going to be much larger than what you would have in something like Excel, right? They offer the ability. They're also more efficient for what we call querying the information that's in there. What do we mean when we say query? Yeah, Aiden?
Getting the information and inserting it back.
Getting the information out. It's really, what is a query? Just the word query by default. If I say I have a query, what do I mean?
Question.
It's a question, right? So I'm asking did you say question, Levi? Is that you? Okay. I'm asking the database a question. I want some information back, right? I want to know how many people were born after the year 1941 because I've got this huge database of information that's got date of births in it, right? So that's my question, that's my query, and the database is going to return all that information to me. So databases are more efficient as far as querying large sets of data like that. They offer the ability you can relate tables to one another. So like this may represent one table that I have, and maybe this is my customer table, customers, and then over here is my this is my orders, right? I think these are things that are sort of in the database that I'm going to show you online. Maybe we'll get to that today. So these are orders that are made by my customers, right? And I've got a whole other set of data here. But obviously, in my customer information table, I'm a customer in here, my address is in here, my phone number is in here. If I place an order, I don't want to duplicate all that information in my order table. I instead want to say, hey, this order was placed by Jamie Walker over here in the customer table. So if you need all that information, go back over here and look that information up from this table, right? So you can relate tables to one another like that. We'll learn how to do that. They have query languages, robust query languages for getting that information out. And so we're going to dig into one of those query languages called SQL. Has anybody heard of SQL? Yeah, I see one person shaking their head. Can I get a second? Just a yawn. Wow. Okay. Nothing hurts your esteem as a teacher like a big yawn right in the middle of the halls. Yeah. Somebody get that man some coffee. All right, so SQL stands for Structured Query Language. There's our word query, right? And so that's a language designed for retrieving information from databases. Also, you use it for inserting and updating information in the database as well. So we're going to learn about SQL, and will really be the first time that we've done something in here. We tiptoed in it a little bit in our spreadsheet exercise where we did some programming type stuff, but this will be more programming type. You're writing something that has to be structured in a particular way, and you're interacting with the computer or with the database in this case, and it's doing what you want it to do based on the instructions you're giving it. Yes?
Sorry, quick question. Are we having an assignment this week on querying databases?
No, this week it's just going to be, what is your assignment this week? I think this week is an easy, hey, see, so since you didn't want to have all these tests at the same time, this week you don't actually have an assignment where you're turning something in. Your assignment is just to study the information to be ready for the quiz that we're not going to take next week because we're going to take the test instead. So how about that? Huh? That'll help. All right. Absolutely. So thank you after that yawn a moment ago. That really helps me out. But there's remote availability when you're working with databases, so I can access this from anywhere in the world as long as I have internet access. I can again with Microsoft putting stuff in the cloud, right? You can access Excel in the cloud now, so and Google the same way. I can access my Google Sheets from somewhere. So that piece may not be as awesome, but you also have, with databases, you can have redundant environments for your databases. So if one goes down, one server goes down and automatically the other one, it jumps to the other one, or maybe it's writing to two databases at the same time as you're interacting with it and recording data in both places. So if one goes down, your website can still be up and running. Things like that. There are a lot of possibilities with databases that you don't get with spreadsheets. Databases, though, are all about the data, right? That is the focus of a database. With a spreadsheet, we could do fancy things like put borders around certain portions, right? Put colors on there, put charts on there. There was all this presentation side of spreadsheets. Okay, I thought something exciting was happening. You guys keep looking up there. And you're trying to tell me with your eyes. You can point to one right here, Mr. Walker, right? So, we've got colors up here, right? Grays and blues and whatever that yellow or orange is over there. And a nice fancy chart and different borders, and we can left justify certain text and center others and all that kind of stuff. Databases don't know anything about that. Database is not about presentation, right? It's just about storing the raw data. It's really good at handling the raw data. That's why it's so efficient at you being able to retrieve those records and insert large amounts of data and all that kind of stuff. So we don't have to worry about any of the presentation side. Databases are all about simply storing raw data. Right? Storing that raw data and retrieving it efficiently. That's its job. Like I said, it's for large data sets, unlike the spreadsheet scenario. So obviously you want to view that data, so we use other environments to other applications to present the data in a visually pleasing way. So we might build a website, right? You're looking at Amazon, you're looking at mountains and mountains of data, right? As you're interacting with Amazon, but you've got this nice website or this nice phone application, right? That lets you view that data that's stored in their database. I mean, imagine what their databases are like of their product information, right? Just mounds and mounds and mounds of data. Did we talk about all the data? Yeah, we talked about that last time, right? Google, Microsoft, Amazon, and Facebook about how much information they use. 1,200 petabytes or petabytes. Did we actually talk about that last time? We did. So that's 1.2 million terabytes, massive amounts of data. But when you're storing information, like I said, you've got rows and columns, right? Just like you have in your spreadsheet. But it's all about the data. And we're going to dig a little more into that, especially when we start using SQL about what that data looks like, how you define the types of data. You have to specify that when you're working with a database. We can just start entering information in Excel and we don't really have to tell it what it is. Excel tries to sort of figure it out, right? Is there something that I need to know? Something particularly funny? No? Okay. All right. Just making sure. My hair sticking up in the back? A little bit? Okay. It does kind of sprout up right back here. So, but the database isn't going to make a guess on that. You're going to create a field and you're going to say it's a field of this type. If you're wanting to store a number in there, you're going to tell it what kind of number. You're going to say if you may define the precision of the numbers that are in there, or if it's a float versus an integer or something like that. I don't even know if you're familiar with those terms, but we'll definitely learn about that when we get more into the programming side of things. Or if it's text, or if it's money, or whatever. So we'll have to specify that information when we create our database column or database field. So when you consider databases, consistency is important. What do we mean by consistency? In other words, if you have data across multiple tables, your data should be consistent, right? So if I have information, like I said, if I'm a customer and there's information about me and I've entered in that my phone number is my cell phone number and that's my primary phone number, then if that data is duplicated anywhere throughout my database, it should say the same, right? It should say that is my primary phone number. That should be consistent across the top. So consistency is a big deal when we talk about database information. If we had a database that for Konos here, and we may not be managing the databases, but we're using something like GradeLink and we're using Google Classroom, and all of that information is stored in databases somewhere, right? So databases of information that has a list of students and the classes that they're taking. If one table says that you're taking the computer science class, and then I run a query against the database that's going against a different table and says list all the students in the computer science class, well, it better include you, right? Maybe there's a table that's like the student table that says here's the classes that Tony's taken, right? And then we go over to the computer science class and here's the list of students. Tony better be in there, right? Skateboard and all, right, buddy? And so that data has to be consistent across the board, right? So consistency is a big deal. How can data become inconsistent when you're entering information in databases? Well, suppose you get an error, right? Maybe you're in the middle of a transaction and you're trying to insert some data into the database, and for whatever reason that transaction can't be completed. Maybe we were updating the student table and we said Tony's in the computer science class, he's taking that class, right, in the student table. What's so funny, huh? Then we go over to the computer science class and we're entering in the list of students, and we're in the middle of inserting Tony's information into that, and my computer dies, or there's an internet issue and that never goes through. So now we've got inconsistent information. So what do we do to help get around, help eliminate that type of inconsistency? So we're going to talk about some of that. Here's an interesting term. Idempotency. Anybody ever heard of that? Nobody's ever heard of that? Really? Yeah, I hadn't really heard about it until I read the book either, so I'm with you. Idempotency, what does that mean? It means an operation will result, an operation results in the same result no matter how many times it's performed. So this is kind of a list of things. How do we maintain consistency of data in our database? All right, that's the question that we're asking. And here's some things that we think about as we're creating our databases. We're striving for idempotency. What does that mean? Well, it means, like, for example, I am, just to use Tony again as an example. Tony wants a new skateboard, right? So Tony's going on Amazon and he's ordered this new skateboard, and he gets down to the very end, he's got it in his cart, and it says purchase, and he clicks it. And have you ever done this? Has your finger, maybe you've been working too long on the computer and I don't know, maybe your muscles are just kind of jumpy, but you go to click it and you mean to click it once and you accidentally double click something? That's a pain, right? Especially if you're making like a $1,000 skateboard purchase, because Tony, you're a big deal, right? So you don't buy these little cheap things. He's spending lots of money, high quality skateboards that are going to last for a long time. And so he actually, the muscle there is kind of jumpy. He purchases 2 skateboards accidentally. Well, idempotency would have helped with that scenario, right? Because it knew, it was kind of tracking his progress as he was building that order, and it knew for this order here, we're only going to want to submit that order one time. So there would have been some processes in place to keep you from doing that transaction more than once. No matter how many times I try to do that transaction, Tony's only buying 1 skateboard, right? That visit. So it's that kind of idea, right? That's just the type of scenario that we're talking about. So we're trying to avoid things happening more than once that should only happen one time. One way that we might achieve this is something called write-ahead logging. Write-ahead logging, there's a dash there. So what do? You write all changes to a log before applying changes to the database. So you're keeping somewhere else track of all the stuff that you're planning to do to the database, but you don't try to do it to the database in piecemeal as you're going along. you write all these changes to a log, and then there's like a final step that applies it all to the database. And once that final step happens, like in the case of a purchase maybe, once that purchase happens, it's no longer in the log anymore, and so you're not going to run the risk of accidentally applying that information to the database again. So that's one way that we might do that. All the steps have to be in place in order for the changes to. All steps must be completed before changes are written to the database. So we call this called atomic transactions. Atomic transactions the idea is either all steps occur or none do. So for atomic transactions, if you don't do any, if you skip a step, nothing will be finally processed. Nothing will be written to the database, right? So that's what we mean when we say atomic transactions. You have to complete all the steps. If a step is not completed, then we perform what we call a rollback. So if any part fails along the way, we roll back. So then that just means return to the original state. When we talk about rolling back. And I'm asking myself, why did I get down to here and I've cut off everything that I'm writing here and I extended this on out? Did you guys see that? That doesn't make any sense, does it? So here's what I'm going to do. I'm going to roll back those changes that I just made. We're going to roll back, right? And then we're going to write it right here. Okay, and I totally meant to do that on purpose. Yeah, I was thinking that ahead of time. We roll back, so we undo, return to original state. So that's what rollback means. Yes?
After you said all steps must, what does that word say?
Must, it says completed, but normally you would have a helping verb there. The verb be would be really useful. So all steps must be completed before changes are written to the database. All right? So this is just kind of, these are definitions, right, that's related to this idea of maintaining consistency, because that's a big deal in the database. You don't want your data to be out of sync. Like I said, errors throughout the process can cause, look at this, maintain consistency of data in our database. Check that out. Some kind of new product that's I'm working on the side. I wasn't going to reveal that yet. It's not ready for prime time. So we'll just talk. We'll confine our discussion to databases. Okay. So how do we maintain consistency of data in our database? There we go. Like I said, errors can cause these inconsistencies. So when we're trying to prevent these errors, one way that we can prevent errors is by locking a record so that no one else can write while we've got the record locked. So if you've ever worked on a document online with multiple people, the system probably had some sort of locking mechanism on there, right? Where you can't edit this file because someone's in the middle of editing it right now. Have you guys ever seen anything like that? You ever worked in it? Can anybody tell me like an environment you've worked in that kind of handled things that way? I know that I've done it online with some of the tools at my previous job where I might be updating a record, like in Microsoft SharePoint, which is a way that we could store information. It's kind of like databases, like database information. The database is behind the scenes, but it would do that. Like if I'm updating someone's record, it wouldn't let anybody else update it while I was in the middle of updating it. Maybe if you share, I don't know how Google handles, like how does it handle shared spreadsheets and stuff like that, shared documents online? Do you guys ever run into a scenario where you've got something shared with other people?
I feel like I did a long time ago when I was younger.
You would think it would have to do something like that, you know?
Yeah. I think
Where it's saved in the data because it doesn't want doesn't want changes to be saved that go into place and overwrite what someone else has done, you know? Yes?
I think it might be with Google Sheets. I think it'll keep like a saved database if it's been changed.
Okay.
But I know like with Google Docs, anybody can just edit it. Like, you can edit over someone else editing.
All at the same time?
Mm-hmm.
So it has to keep up with a history or something, so maybe you can see the changes that were made. Yes?
I believe it stores a local copy for each change that's made, and then every few seconds it pushes all the
It pushes it out. Yeah, that's kind of what I've seen as I've been working on documents. It's constantly saving it, right? And so that means what should be happening is as you're working on stuff, if someone happened to be working on the same paragraph in a document that you were, all of a sudden more information shows up in your document, right? So that's kind of a strange experience, but they just have to have some way to keep people from overriding other person's information. And the way that some systems work, and some databases will give you this option, is that you can lock a record so that two people can't edit the same record at the same time, right? The problem with that is you may enter a state of what's called deadlock. So just to define that term for you, deadlock is two transactions. Excuse me. Two transactions are trying to lock the same row at the same time. And so in a case like this, you would do something like maybe roll back one transaction to let the other one finish, and then attempt the second transaction after that one's already completed. Have to have some scenario for handling the deadlock possibility. Something else we can do to kind of help with consistency is there's something called two-phase commit protocol. Two-phase commit protocol. And this is a standardized way for databases to make sure all transactions are able to write without any inconsistencies before committing. And let me know as I'm saying some of these things, like when I think about the term before committing, what do I mean by that? That means like I'm committing all those changes to the database. I'm writing everything, all those changes to the database now. So if I use any language that you're like, I don't know what you mean by that, let me know that. Because sometimes you've talked about these things and used the current lingo so long, you just kind of use a term and you're not realizing that somebody that's maybe never had any exposure to databases, they're not even figuring out, they're not following what you're talking about. So let me know if that's the case. That's what we mean when we say commit. It's like we commit all those final changes. We apply all of those final changes to the database, right? So two-phase commit protocol says we're going to make sure before we allow you to commit these changes that there's nothing that's going to prevent that from happening. And then it tries to commit. And that way you don't have it starting down the process of updating this table over here and updating this table over here, only to find out that it can't update this table here. So like when we're talking about deadlocks, locked records, and things like that, it makes sure everything is able to, is available and open to it so it can commit all those changes. And so the goal, when you have all these processes in place, you're trying to achieve what we call fault tolerance. Can anybody tell me does anybody know what that term means? If I'm trying to make the system to be fault tolerant, yes.
It's basically not affected by any faults. It can't have any faults because it has so many checks against it.
Yeah. So it's all these balances and checks to make sure that if an error pops up, that error is not going to bring the system to a screeching halt, right? And man, that's like just a big part of programming in general, right? As we get into computer programming, one of the things that you're trying to do as you're writing your code is you're trying to think, this is how I'm designing this thing to work, but this guy over here might not realize that, and he might try to do this. So if he tries to do this, which the system is not designed for, then how am I going to handle that issue, right? So this concept of fault tolerance is something that we're always thinking of in the computer, in the programming world, and just in the computer science world in general. How do I handle it if an error pops up? I don't want that to bring the system down. I don't want there to be incorrect data. I'm trying to handle that gracefully. And it's basically, to give you a definition, it's the ability of a system to continue to run properly. Does not look like properly. To continue to run properly, even if a piece fails. And these failures are what we call faults. That's why we say fault tolerance or fault tolerant. So it's basically a world with no more blue screens of death. You guys know what I mean by that? If you got a Windows machine, you know about the blue screen of death, right? I just did something, I don't know what happened. I was actually doing nothing that seemed like it was significant at all, and all of a sudden, there's the blue screen. Wow. You know, do you want me to send this diagnostic information to Microsoft so that they can help troubleshoot the issue? Sure. Do you ever hear anything back on that? Never.
The red ring too for the Xbox 360.
Yes.
What is it now?
It's like a red ring of death.
A red ring of death?
Yeah, so like you would have the on button on an Xbox 360.
Right.
It would usually go green when it was good. If there was a red ring, then like half the systems that would corrupt or something like that, right? Green?
Yeah, if you got the red ring of death, you weren't getting it back.
Really? It was gone for good.
You
So,
moved it whenever the game was playing.
Yeah, it was.
oh really?
Yeah, it was something so stupid and it killed like half the system.
Interesting.
So like, you had like the blue screen of death, they call it the red ring of death.
So yeah, that is not fault tolerant, right? I mean, there was an issue, there was something that happened that wasn't supposed to happen, but it's like, really? Nobody ever thought that they might move the system while someone's in the middle of playing a game? Those kind of things happen, right? So you're having to think about all that. And here's the reality. Are we ever going to build systems that are truly fault tolerant? Why not?
Everything's not invincible.
What?
Nothing's invincible.
Nothing's invincible. It's because we're not fault-free, right? we're not faultless. It's the biblical principle that only God is all-knowing. You know, He's all-wise. He sees it all. He knows it all. He's able to do it all. And so I just can't think of all those. It just is it's a testimony to my inadequacy, right? I'm just not smart enough to figure out every possibility. Yes.
Isn't it also it's like that? I'm saying it's not future proof or anything in terms of what is to come.
Right.
In terms of like technology and software and firmware. Like who thinks something that today is so high tech that in 20 years it's gonna look like it's Nintendo 64.
Yeah, right.
Graphics and such on. So.
Right. Yeah. Yeah. So advancements. I mean, that kind of goes along with the idea of God too. He knows what's in the future. I don't. Right. And so it kind of speaks to the limited nature of man. It's a good example of, you know, programming is a very humbling experience as far as that goes, because you realize it's like, man, like just like moving the system while someone's in the middle of playing game. Why didn't we think of that? You know? Yes.
Library updates too, if you're using a specific external library.
Yep.
I did one thing with databases, and they decrypted one of the find keys. So the whole find system I had just broke.
Everything broke, right? Because you were dependent on something else that got updated, and now none of my stuff works because of that. Yep. So that's why we're having to. A system update comes out on your phone, and now you have to update all your applications. Why? Because the base code that all of those different applications we're using has now changed. The underlying stuff has changed, and everybody's got to update their stuff to make sure it's going to work going forward. You know. So yeah, there's lots of ways that can break down. So fault tolerance is about trying to make that breakdown be as the least amount of pain possible is involved in that breakdown, right? And you want the system to basically recover and not. So you guys are saying, like, when you got the red ring of death, like that Xbox was totally shot, it was never coming back again?
Wasn't it gone?
I don't think you can get it back.
Wow! All right. So anyway, let's talk about what time we go until when?
3:30.
3:30. Okay, good. I feel like I'm moving a little bit slower pace today, so let's get I at least want us to get to where we can, Lord willing, next week begin to look at the SQL language. And maybe I'll just show you guys a little bit of that online as we start to get there. But a lot of databases allow you to store data in multiple tables that are connected together. These tables relate to one another in some way. And so we call those relational databases. All right, you ever heard that term, relational databases? If you haven't heard that term, it's okay. I forgive you. Okay? I forgive you, buddy. You're good. All right? But relational databases are, that's most of my professional career. I've spent my time working with relational databases. And so they use relational databases use unique keys. Which are these keys are it's a column. Let's see. A column holding a unique value that distinguishes each record from another. So, for example, our scenario with purchasing, we've got customers. Our customers table here. And let's just say we've got a row here that contains, this is the name. This is I'm going to do first name, last name, address, city, whatever. You know, that kind of information. We could go on and on and on. And so I put down my information, and this is Jamie, right? And so we got another record, and let's see. Who have I not picked on today? I don't think I picked on you, Sean. Did I pick on you in the other class? Okay, it's your time, buddy. All right, Sean. Whatever. We'll put one more person in here. They want to volunteer? Isaac's volunteering. All right, good. That's good. See, that's how you get your name on the board right there. Just Isaac learned something last time when Hudson said, "Sure, you can use mine." Right? You're learning. All right, so he's going to live on 3 another street. But tell you what, we'll change you to Drive. All right, so we got a Way, Street, and a Drive. Okay, so we've got all these customers in here, and then we've got this orders table, right? And let's say that I'm purchasing, so this is my purchase and number, maybe we have like number of items, this is my order, number of items, so it's going to be 1, and it's going to be description right here, DSC. So I want to buy reading glasses because I'm old and I can't see very well. All right. So 1 reading glasses, and then that's maybe price, whatever, right? And they're really cheap, so they're going to be $2.50. All right, so I purchased that, so how is the system going to know that I purchased that? Well, I mean, it can record here, maybe we have a purchase by field, and maybe this field contains Jamie Walker. Okay, cool. So then I know that this is the guy that did it, and I know his address and his city and all that. What's the problem?
Payment.
Huh?
Payment.
Payment. What's the problem if there are more people than just the people we have in this class? Aiden?
There's going to be another person named Jamie Walker probably.
That's a super cool name. So of course there are a lot of people out there with that name. Clearly, right? It would make perfect sense. So that's going to be a bad deal because which Jamie Walker is the one that actually purchased it if there's multiple Jamie Walkers in the database, right? So what do? It's this idea of a key. So what we do is we have what we call a primary key field, and we'll just call that, we'll abbreviate that and say it's ID, customer ID, right? And what we're going to do is we're just going to put a numeric value in here, and that numeric value can never be repeated. There can be no other row that has that numeric value in that column, all right? And so when I say that this is purchased by, then instead of putting Jamie Walker, we just put the number 1. I don't think I'm number 1. That was unintentional, okay? I know Brady's like, well, you are number 1, dude. I get it, Brady. I know. Thanks, buddy. Thanks for the vote of confidence. So purchased by me, and so now it's real easy, right? If Isaac comes in here and Isaac wants us to purchase 2, he's thinking that the COVID thing's going to kick up again, and he better get 2 barrels of toilet paper, all right? Because we run out of toilet paper every time that happens. And so he's a big spender, so that was like $200 for that. Well, it's purchased by customer ID number 3, right? And so it's very easy for us to know when we look at the orders table which customer did that, and I don't have to duplicate this information. So that'll help with our consistency, right? I didn't write down Jamie Walker, I didn't write down the address or the city, I just wrote the unique number that points back to this particular column. So what that means is there's got to be something internally in the database that says this purchase by column here relates to the cust ID in the customers table. So there are these key values, and what we call this here, in this table, it's the primary key. But when you use that primary key in a different table, then we call this the foreign key. So it's a key value, it's a unique value, but it's foreign to this table. It's not the key value for this table, it's coming from a different table. All right? So relational databases are going to give you this ability with the primary key and foreign key values. You'll be able to set those up with relational databases. very easy to build those relationships between the two. Let's see, what else can we do? They mentioned that you can create virtual tables. Can create virtual tables, and virtual tables are nice because maybe for the use of this particular scenario, maybe I want to query my order table, but I want my order table not to just have the customer ID when I get that information back. I want it to be a combination of like this table and this table together. Okay, so I'm returning my order table, and it's also going to include the first name and the last name and the address and the city and all that kind of stuff. I wouldn't want that to be there all the time because it's very inefficient, right? I wouldn't want to duplicate storing Jamie Walker, when I keep purchasing reading glasses or whatever through the site. I don't want Jamie Walker to be in there multiple times. It's much less data if I just use this ID here. But just for this particular scenario, I want to return it with all that information in it, so I can create a virtual table that's just kind of hanging out there. It's not a hard table like here, but it's a table that kind of stays in place. It could be temporary. I could delete it later. Maybe I'll leave it there for a time because it's something that I use all the time. Maybe for efficiency purposes, I'll leave that there. But it's generally a temporary table comprised of data from other tables. All right, so that's handy. This kind of stuff, you don't think about spreadsheets at all with this kind of stuff, right? So databases have a lot to bring to the table with this kind of scenario. So that's kind of a high-level overview, right, of databases and how they work, and sticking our toes in the water when it comes to relational databases. And we're actually going to work with SQL. I'm going to show you some of that in just a minute. But I do want to know, are there any general questions just about databases? Are you confused about what I mean? When I talk about tables and fields and columns and rows and stuff like that, is there anything that's kind of confusing you? Relationships, keys, anything that doesn't make sense? Are you guys fixing your hair, or are you saying no? No, okay, all right. It's just fun to do, right? All right, well, let's see I want to show you what we're going to use for learning about SQL, right? For querying some of these tables, and kind of give you an overview of what's available online. Has anybody ever heard of W3 Schools? So W3 Schools, I think it's .org. Not schools. W3schools.org. Let me make sure that's correct. It might be .com. Oh, it is .com. All right, so W3 Schools. I'll zoom in a little bit here so maybe everybody in the back can see it. If you just go to the home page, right, this is a place you can go to learn HTML. CSS stands for Cascading Style Sheets. That's something we're going to learn about in here. The JavaScript programming language, arguably the most popular language that's out there right now. Just about the websites aren't entirely necessarily built on it, though they could be, but they definitely probably use JavaScript to some degree. Any website that you visit. Python, here's SQL, we're going to learn about that, and a bunch of others, PHP, jQuery, Java, C++, right? So we're going to go to learn SQL. So that takes me to the SQL tutorial page. Unfortunately, there's a bunch of ads. They'll pull them down the side and up the top, so you're going to have to deal with those as you're on here. But a lot of great information. And when we're using W3 Schools, when I give you assignments here, I'm going to refer to the areas on the left that I want you to read. Okay? So I'll say basically read through SQL home down through SQL where, or I may just say home through where. Right? That's what I'm intending to try to get through next week. Since we're going to take the test in class, I don't know that that's going to happen, but I'm hoping to get through those 1, 2, 3, 4, 5, 6 sections there. But what's really useful with the way that they set up all this stuff, they do it with JavaScript and CSS and HTML, is anytime you learn something, they will give you an example, and then they'll say, try it yourself. So you can always just click this try it yourself button here, And this is a statement that's going to let me select the information that's in my customers table. And where's the database? Is it because I made it too big? Let's see. Nope.
Maybe hypothetical.
No, it's actually there on some of the other examples, but maybe let me go down here to the where. I know when I did it here in the where that it was there. What in the world? That is really bizarre.
Is it just keeping it on another tab?
Oh, there it goes. When I run it, then it shows me my tables. Okay. So I have to like click run for the first time. So let me go back to my whoops, back a little too far, w3schools.com/SQL. Okay, home, we'll go to try it yourself, customers, there they are. All right, so we've got, our database is made up of a table called customers, categories, employees, order details, orders, products, shippers, and suppliers. This tells us how many records are in that particular table. Records correspond to rows, right? So when you see rows, just think of records. I'm not going to write that down because I'm not going to remember to edit that into the video. But rows and records are the same things. If I view, this is the SQL statement. We'll talk about this in greater detail next week. But this is the SQL statement that I would write to return all of the information that's in my customers table. So if I run that, I can look down here and I can see that there's a field called customer ID. You can think of that as the column. This column contains information that is the customer ID information for that particular record, right? This is the customer name field, the contact name field. You'll notice that we don't ever put spaces. We don't generally put spaces in the column names or in the field names. Some databases may allow it, but it's not common practice. So I'd kind of stay away from that. And country. So that's all the information that's in the customer table. And just like I showed you up there with the primary key thing, it starts off with 1, 2. So all of these customers are going to be identified by a unique number here that will never repeat. I could never enter a record in here that had the same customer ID. So you can always assume that that ID is going to be unique. So anywhere else in my database, if I refer back to customer ID 1, it's always going to be this Alfred's Futterkist, all right? Because that's a very common name there. So we want to make sure we have a unique code associated with that. But that's a database table, right? Really plain Jane, generic information. Like I said, one of the things that you will have to specify when we're creating these fields in the database is we'll have to specify the type of field. So this field right here, all of this is numerical data. And it's actually a specific kind of field that's going to automatically increment. What do I mean when I say increment? Somebody besides Aiden. Preston, do you know what I mean when I say increment that value? Anybody? Yeah. Do what? Level it? Is that what you said? No. What, Braden? It's just adding a 1. Yeah, we're incrementing, we're building on it. So when you did this here, I thought you were talking about like building. So we're building it up by adding 1 to it each time. Okay, so that's all that's talking about. But you took a stab, right? So that's what it's getting. Is your name on the board yet? All right. It's the danger. I'm just going to write it down because I'll look it up when I get home. I'll know who Tony is, right? Preston, I called on you. If you had volunteered, man, you know, I could have written your name on the board. But that's going to automatically, in other words, if I enter in another row of data, I don't have to specify the customer ID. It'll just look at whatever's the last customer ID in here, and it'll add 1 to it and enter that number. So the next record that gets entered will have a 92 there automatically. These other values these will be text fields, right? And you can specify in the database when you define the field, like how many characters are allowed in that field and things like that. So you can limit the amount of information that's put there. Like postal code, for instance, some of these postal codes are really weird. So we couldn't just say the postal code field is numeric, but we might say, you know what, postal code should never be bigger than, I don't know, 12 characters. And so we may limit the field and say it can't be any bigger than that. And that'll just help our, if we limit the size, limit it to a specific size, that'll help our storage space that's required for our database when it's stored on the servers. So that's a basic table. And if I go to something like, let's go to order details, I'm guessing, yeah, look at order details. Order details only has an order ID, a product ID. It's interesting, a customer ID must be contained in the order ID, but notice it doesn't contain any, there's no meaningful information that I can read here and figure out what it's talking about. I'm going to have to go to like the order details table, I guess. It's got 580. No, was that where I already clicked on? Maybe that's what I already clicked on. Yeah. If I go to the orders table, then that will tell me which customer placed that order. It'll tell me the date that's there, but notice it doesn't repeat the customer information. It just says it was customer 90. So if I go back to the customers table, I know that the user that submitted that was Wilman Kala. Who are these people? Where did they come from? There's like a family, the businesses in there as well. So yeah, that makes sense. Some of these are business accounts. This is like a generic database that comes with Microsoft SQL Server database, I think is what this is. It's called the Northwind database. So I think that's where all this information is coming from here. But yeah, this is a small one. This will be a good one for us to work with. So we're going to learn how to select data back from that, how to insert data into it, update data that's there. You might want to delete data, right? That's obviously something that you might need to do. So we're going to find out how to do all of that stuff. Any final questions? Let me make sure there's nothing else in my notes about what we're going to be spending the next few weeks going over, and any questions about the test next week. Anyone? Anyone? Oh, Hudson. Yes.
So for the test next week, is it over like the last 2 chapters? Because I know
I don't have one over chapter 2.
Well, more so the rest of it. It's just like the Huffman tree, how to like basic, lossless data, metadata. There's a bunch of stuff like that.
Yep. So anything in chapter 2 is fair game.
So like chapter 2 to 3.
I'm not chapter 2. I meant chapter 3. Anything in chapter 3 is fair game. It will not be over chapter 2. Chapter 2 was kind of a weird one with the graphics stuff, and a lot of that was just sort of like finding out about Photoshop, right? Or GIMP, like you guys played around with GIMP. So it was just kind of the basics of that.
I forget the name, but for this one, we just have to know how it works, not the how to like.
Yeah, so we had that on a quiz, right? Where I kind of gave you, I said, just sort of explain to me how this would work. And so the idea, that's an example of run length encoding, right? And so you figure out the runs, how the patterns that are repeating, and how many of those there are. So there's black, white, black, white. So that's my pattern, black, white. And it's a run of 4 of those or something like that, right? So you just need to kind of explain how it works.
That's what I was asking for. We don't have to like spell it out. But we do it for the Huffman tree.
For the Huffman tree, you will. Yeah, I will give you a sample word, and I'll expect you to know how to build a Huffman tree from that. And you should be able to tell me if the original word is an ASCII. You should be able to tell me how many bits you're saving when you create your Huffman tree.
And that's just by timing how many like syllables it hit, right? How many bits you get.
How many? The number of characters. Number of letters, including spaces. Number of characters times 8. That's right. That's what ASCII would be. Yep. Anything else? Okay. That's it for today, guys. A pretty easy week, right? What I do want you to do, there will be a reading assignment. Okay. And I've got an online article that I want you to read just about relational databases. That will kind of get us ready for jumping into SQL, just so you have a little bit of background there and to make sure you're familiar with relational databases. Okay? Test next week. Everybody got it? All right. Excellent. Have a good one.